In this video, we are going to learn how to solve trickier inequalities. So the last video reviewed the basics of how to solve an algebraic inequality. Now we're going to tackle three situations that might come up. One of them is a compound inequality. The next is an absolute value inequality. And the final one is a quadratic inequality. We thought we'd left quadratics behind. Not so fast. Quadratic inequality. Okay, so let's do compound inequalities first. So those are the ones where you have two inequalities within the same thing. So at its most basic, if you've never seen these before, a compound inequality might be like x is greater than or equal to -4 but less than 10. So that one doesn't need any solving. That's like already solved. That one's done. But you could graph it on a number line and you might have -4 here. You might have 10 here. And let's see, it's greater than or equal to -4. So that would be a closed dot on -4, but it's less than 10. So that means it's everything in between those. So then you would shade in that region in there, showing that numbers like -3 or 5 or 0 would all work because they're all bigger than -4, but less than 10. Now, what we want is to get it to look like this. So let's say we start out with 2x plus 5 is greater than or equal to 1, but less than or equal to 15. So I'm going to recommend that our first step be to split it into two different inequalities. So split into two inequalities. Ooh. And those two inequalities are going to be the two that go with each answer, right? So one of them is going to be 1 is less than or equal to 2x plus 5. That's like the first part. The other one will be 2x plus 5 is less than or equal to 15. So I just did that part and that part. And then I'm going to solve each one. Being careful, of course, about dividing by negatives or multiplying by negatives. So first one, I'm going to subtract 5 from both sides. -4 is less than or equal to 2x. I'll divide by 2. Do I need to flip it? I'm dividing. There's a negative. But no, because I'm not dividing by a negative. I'm dividing a negative, but that's different from dividing by a negative. The number I'm dividing by is positive. So x is greater than or equal to -2. So that's half my answer. I'm going to do the other part. 2x is less than or equal to 10. Divide by 2. X is less than 5. So my final answer is going to be x is greater than or equal to -2 and less than, should have been still been an or equal to, less than or equal to 5. And I can stick that on a number line to show -2, -1, 0, 1, 2, 3, 4, 5. These numbers are kind of close to each other, so I might as well do the scale properly. And they both get closed dots because they're both or equal to, and it's less than 5 but greater than -2. So it would be all this stuff in between. All right, next let's look at what happens if you have an absolute value and an inequality in the same equation. So let's take x, the absolute value of x plus 6. So I have some unknown number, I add 6 to it, and then I take the absolute value of that. And the result, what comes out of there, needs to be less than 20. Now, we very briefly covered solving absolute value equations earlier this year. We just did it with an equal sign instead of with an inequality. And what we thought about then was how if I think about this stuff in here, before I take the absolute value, it either needs to be less than 20 or it needs to be like greater than negative 20. So like if we think about, if I just replace that with like a green box, some unknown thing, I take the absolute value of it and it needs to be less than 20. What things could go in there? 19 could go in there, or negative 19, because they both, the absolute value of them is less than 20, right? 18 or negative 18, etc. Does 20 work? No, because 20 is equal to. So I'm going to split this into two equations like I did before. I'm going to say that the absolute value of the stuff, which is x plus 6, must be, or sorry, I'm going to say, at this point I'm taking away the absolute value signs. So I'm saying that the stuff must be less than 20, or the stuff must be greater than negative 20, right? Because numbers greater than negative 20 are like negative 19, negative 18, negative 17. They're like stuff that's above it on a number line. And so then I solve both of these. And actually, in this situation, it's not an or, right? It has to be both, because not everything below 20 will work, and not everything above negative 20 will work. It has to be like both of them. So that can't be an or, that has to be an and. So then I'll solve both, minus 6. So x is less than 14, and x is greater than negative 26. And then I can write that back as a compound inequality. So x is less than 14 and greater than negative 26. And it's always a good idea, like especially if what I did over here was super confusing, it's always a good idea to plug numbers back in and make sure that this works. So let's say I have 14 over here. Let's pretend that's negative 26. I'm doing open dots this time, and it's everything in between. And so then I pick some numbers in the middle, like maybe I'll pick 10 and negative 2. And I just like try those back in the original. So does the absolute value of x plus negative 2 is, or sorry, negative 2 plus 6, is that less than 20? Absolute value, negative 2 plus 6 is 4. Is the absolute value of 4 less than 20? Is 4 less than 20? Yes, it is, so that one works. What about 10? Absolute value of 10 plus 6. Is that less than 20? Absolute value of 16 less than 20. 16 is less than 20, so yes, that works. That makes me feel more confident in my answer. So in short, what I did here was I took the stuff inside. I did not change it. I just took away the absolute values, and then one of them I kept the same. That one was the same. And the other one, I flipped it and made it negative. So one of them is the same. The other one is flip and negative, which sort of makes sense if you think about our rule that when you like make something on the other side negative, if you like divide, if you switch the sign on the other side, you have to switch the inequality. All right, finally, you might see a quadratic inequality if you're super lucky. So here we have some strategies for solving. Most of them involve zeroing out one side, right? So let's do that. So let's, and actually our very first step is going to be to change to a equation. So we're just going to rewrite it as an equation. We're going to solve it, and then we're going to come back to it later. So I'm going to rewrite it as x squared plus 7x plus 15 equals 3. And then at the end, we're going to come back and like test points to figure out which way the inequality should go. So I'm going to subtract 3. X squared plus 7x plus 12 equals 0. And now I have a choice. I can factor. I can do quadratic formula. Like it equals 0. So I have choices now. I'm going to factor. And if I do a box and diamond on this, I'm going to find that, let's see, two numbers that multiply to 12 could be 3 and 4. And 3 and 4 happen to add to 7. So x plus 3, x plus 4 equals 0. So that means x must equal -3 or -4. Woohoo! These are my boundary points. So just like on the last examples, there's going to be two spots where like things switch from working to not working. So I'm going to put that on a number line. So we're going to have, here's -4, here's -3. And I don't know, and then this is doesn't have an equal sign on it, so I know they're going to be open dots. Because back in the original, there was no equal sign. And then I need to figure out, is it going to be the stuff in between that works? Or is it going to be the stuff outside that works? Most of the examples we've done before have been the in-betweens, but sometimes it ends up being the outsides that work. So let's check. So if 0 works, then that would mean that this whole region works. So I'm going to plug 0 into the original. So my first step was change to an equal sign. My second step was find the boundary points. And then I am going to test for solution regions. So I'm going to test 0. So 0 squared plus 7 times 0 plus 15 is greater than 3. Well, that's a 0. That's a 0. So 15 is greater than 3. So that one works. Like so. Okay. And then I'm going to test in between. So what's in between -3 and -4? -3.5. I wanted to see if that works. So -3.5 squared plus 7 times -3.5 plus 15 is greater than 3. I'm going to use a calculator. And when I did that, I got 2.75 is greater than 3, which is not true. So that means this stuff in here is not a solution. So then I'll test smaller numbers. So like maybe I'll test -10. -10 squared plus 7 times -10 plus 15 is greater than 3. So 100 minus 70 plus 15 is greater than 3. Well, 100 minus 70 will be 30 plus 15. Is that greater than 3? Yes, it certainly is. So that means it's all that lower stuff, which means now I need to translate this back into a solution. So that means that x is less than -4 and greater than -3. X is less than -4 and greater than -3. So I tested for solution regions, and then I wrote the compound inequality. And unless there's only one point, right? Like picture a parabola that only touches once. Unless there's only one point, it's always going to be compound, or perhaps no solution. Right, the compound inequality. All right, for your practice problem, let's just do a basic compound inequality. -5x is greater than 30, but less than 50. Please solve, and at the end, check that your answer makes sense. confirm that it works.